All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you should have x plus 11 times x minus 2. For the math knowledge questions, we need to factor this, but first, before we factor, we have to make it equal to 0. So we're going to subtract 10 to make that minus 24. And then when you factor, you're going to have x plus 8 times x minus 3. From there, you're going to set your two factors equal to 0. Because either this is 0 or this one's 0. So x equals negative 8 or x equals positive 3. And the only one they give you is the negative 8. So that's your answer. So we are looking at lesson 31 today. We're going to be looking at flowcharts and paragraph proofs. So hopefully you'll understand how flowcharts and paragraph proofs work after this lesson. So we've already talked about two-column proofs. These are the other types of proofs. And if it just says prove, it doesn't matter which one of the three that you pick. But if it says use a specific one, then you need to make sure to do that. Okay, so a flowchart proof is a style of proof that used boxes and arrows to show the structure of the proof. So we're going to use boxes and arrows. Your flowchart proofs should either be read from left to right or from top to bottom. Typically, top to bottom is how the book is going to set them up, but you can make them go from left to right if you would rather. Each part of your proof is going to be in a box, and then the justification is going to be written underneath the box. So in our flowchart proofs, you're still going to have statements and reasons. Your statements are going to go inside of the box, and your justifications, your reasons, are going to go underneath. The arrows are going to show the progression, so you're just going to follow your arrows to see where you go next. So look here. We have a flowchart proof, and we want to write a two-column proof. So this is what a flowchart proof looks like. We start at the top, and then we go down. Just follow the arrows down. So we're going to start off by making a two-column proof. So we're going to do our statements and our reasons. Okay, so on this one, for time's sake, instead of writing it out completely, we are going to just work through it and try and shorthand it a little bit. So the first thing that you always start with is your given. So where is our given here? Right here. And there's nothing above it in the sense that no arrow is going to this given box. The way it was written, it makes it look like this one should come first, but you usually want to start with your given. So we're going to say given, and then whatever was in here. Okay, so that takes care of that box. From there, these two are at the top, and they point to this box. So these two both have to go before this box here. So step 2 is from the vertical angle theorem, and that takes care of that one. And then step 3 is from the triangle angle sum theorem, and that would take care of that box. Okay? And then you're going to go to what they both point to, which is this one. So we're going to substitute. And then after that, we're going to go to this box, which is a substitution property of equality. And then from there, you would go to your simplify. because that's what leads to next. And then the last one would be your division property. And you would have your information that's inside of the box over there. So on your test, I don't want you to actually do that, but I'm trying to explain it so that we have enough time to practice going over some more of them. So you would write what's in the box over here for your statements, and then your justifications would go here. We have 1, 2, 3, 4, 5, 6, 7 boxes, so we should have 7 statements and reasons over here. So that's how you can go from a flowchart to a 2-column proof. Literally just take the information and you're putting it into a 2-column proof. It's not terribly difficult. They've already given you all the information for the proof. You just have to put it in the correct format. Okay, so given that C is the midpoint of both AE and BE, we want to prove that the triangles are congruent. So we're going to make a flowchart proof here. So we start off with our given information. C is the midpoint of AE, and you put it in a box, and the justification is going to be given. And then you do C is the midpoint of BD. And that's also given. Since C is the midpoint of AE, that means that this segment has to be congruent to that segment. So segment AC is congruent to segment EC. And what would be the justification for those to be congruent? That would be definition of midpoint. Likewise, if C is the midpoint of BD, this segment and that segment are congruent. So that follows from BC being congruent to DC. And again, the reasoning is definition of midpoint. So we're trying to prove that the triangles are congruent. We have 2 sides, but we don't have enough to prove that they are congruent yet. So we need one more piece of information, which is that these angles here are congruent. So angle ACB is congruent to ECD. And the reasoning there would be that they are vertical angles. So I'm not putting it underneath the other 2 or putting arrows from them to it because we don't need the midpoint information to know that they are vertical angles. That's just something that we know from the fact that we know about vertical angles. So from all 3 of these, now we can say that the triangles are congruent. So triangle ABC is congruent to triangle EDC. And the reasoning here would be side angle side. Okay, so that's how that would work. So some people like a flowchart proof better than a 2-column proof. Some people hate flowchart proofs. You do need to be familiar with them because they will show up throughout the year. Not quite as often as 2-column proofs, but they do show up, so you need to understand how they work. Okay, so now we're going to look at paragraph proofs. A paragraph proof is a style of proof where the statements and reasons are presented in paragraph form. So whenever it said explain your reasoning and you've explained it completely, that's kind of like a paragraph proof. You just put all of your thoughts into a paragraph, English sentences. So every step of the proof is explained by a sentence of the paragraph. And each sentence must contain both a statement and your justification. So every sentence will have the statement and justification all together. So here's our paragraph proof, and we want to write a 2-column proof. So I personally think that these are a little more challenging because it's not just take this information and put it into another format. You do have to, I guess, translate it a little bit. It just takes a little bit more effort to rewrite. So statements and reasons. The first statement is always going to be our given. So if you look back in here, it tells you your given is right here. So you can just write your given. MB is parallel to EH. EM is parallel to HB. And the measure of angle MBH equals 90 degrees. So that's the first thing you're going to do. You're given. Now you're going to look at the paragraph proof, and it tells us that MB is a transversal intersecting these. So the same side interior angles are supplementary. So by definition, that means this. Similarly, since these are parallel, these are supplementary. And by the same argument, they're going to be the same 90 degrees. So it said similarly, and then by the same arguments. So we're going to put all three of those together. So angle MBH and EMB are supplementary. And that's because of the same side interior angle theorem. Likewise, EMB and angle MEH are supplementary. And finally, by the same argument, angle MEH and angle EHB are supplementary. Okay, so those are all because of same side interior angles. And so since these are all supplementary, that means that the angle MBH plus angle EMB equals 180 degrees. And the other two also equal 180. So angle EMB plus angle MEH and angle MEH plus angle EHB equals 180. And the reasoning on those would be definition of supplementary. So definition of supplementary angles. It told us that the measure of angle MBH equaled 90 degrees. So we can plug that in here. So we'd have 90 degrees plus angle EMB equals 180 degrees. And that's from substitution. And then if those equal 90, this one also has to equal 90. So angle EMB equals 90. And that's just from the subtraction property. And then if EMB equals 90, then this one also has to equal 90. And if this one equals 90, then that one also has to equal 90. So the book did it like this. Angle MEH equals 90 and angle EHB equals 90. And they just said substitute and simplify for the reasoning, rather than going through and making 4 more steps here. They just made 1. So from there, we now know that all 4 angles are right angles. And the reason would just be the definition of right angles. And so that means that it's a rectangle. And the reason it's a rectangle is just because of the definition of rectangle. A parallelogram with 4 right angles. So if you notice, we didn't really use the paragraph proof a lot when we wrote this 2-column proof. It's there as a little bit of a guide, but I don't find that it's super helpful whenever you're actually writing your proofs. I think it's just there to help you a little bit, but it doesn't give you all of the information that you really need. So paragraph proofs are more condensed. There's less writing for sure. And so some people prefer them just because it does mean you have less writing. Some people hate them. It doesn't matter to me. You do need to learn them though, because they do come in handy. Okay, so on this one, we want to write a paragraph proof showing that the triangles are congruent. So it tells us we are given, it tells us that segment LT is congruent to segment LM, and angle 1 is congruent to angle 2. Okay, so that's what we're given, and we want to show the triangles are congruent. We know from the reflexive property that side BL is congruent to itself. So that takes care of the 2 sides. And then all you have to do now is prove that this angle and this angle are congruent. So the way that you have to do that, this angle 1 is congruent to this angle here, and this angle 2 is congruent to that angle there. That's the first thing you have to do. So angle 1 is congruent to angle BLT, and angle 2 is congruent to angle BLM by vertical angles. Okay, and then by the transitive property, that means that angle BLT is going to be congruent to angle BLM. So then we have side angle side. So by side angle side, triangle BLM is congruent to triangle BLT. So that's how you can write a paragraph proof. Still the same basic information. Some people just like it because it takes up a little bit less writing. Okay, so let's see if you can order this flowchart proof into a 2-column proof by yourself. So what you're going to do, the one that's going to come first are these 2, and I would put both of them together in one statement and just say angle 1 and 2 are complementary, and underneath it angle 1 is congruent to angle 3, and then reason number 1 given. If you want to make them 2 separate given statements, you can though. And then this can be 2, or this one could be 2. The 2 and the 3 can be switched. It doesn't matter. Just one of those needs to be 2 and one of those needs to be 3. And from there, this one would be step 4, and then this one would be step 5. So that's how you would write a 2-column proof from that flow chart. You would put it in a actual 2-column proof, but for time's sake, we're not going to actually write out every single bit of it because I want to make sure we get through all of the examples. Okay, so now we have to prove the vertical angles theorem using a flowchart proof. So we're proving vertical angles, so we can't use the fact that angles 1 and angles 3 are vertical. We actually have to do something else. So the first thing that we're given is A and B intersect. And so that's the given. From there, we know that angle 1 and angle 2 are supplementary. And angle 2 and angle 3 are supplementary. And the reasoning for that would be that they are a linear pair. Okay, so that's what you would do. Next, so if those two are supplementary, we can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And likewise, the measure of angle 2 plus the measure of angle 3 equals 180 degrees. And then this reasoning would just be definition of supplementary. From there, that means that angle 1 plus angle 2 equals angle 2 plus angle 3 because they both equal 180. And so that would just be substitution. From there, we can subtract the measure of angle 2 from both sides, where we just have the measure of angle 1 equals the measure of angle 3. So we would put subtraction for a justification. And then if those two equal each other, that means that angle 1 is congruent to angle 3. And so the reasoning there would be definition of congruent angles. So that would be a flowchart proof for that one. So if y'all got that right, that's awesome. If not, that's okay. You've got to practice these for sure. So don't give up on them, just like you hopefully haven't given up on 2-column proofs just yet. So looking at this one, we want to write a 2-column proof from the given paragraph proof. So it tells you angle 1 and angle 4 are complementary, and you're supposed to prove angle 2 and angle 3 are complementary. Okay, so the first thing you're going to do is your given. Okay. From there, we're going to start off So we're going to say angle 1 and angle 4 are complementary. And then the reason here would be given. From there, it tells us that means that angle 1 and angle 4 equal 90 degrees. So angle 1 plus, well, the measure of angle 1 and that would be definition of complementary angles. And that's from up here where it says it. And then it says angles 1 and 3 and 2 and 4 are congruent. So angles 1 and 3 are congruent. Angles 2 and 4 are congruent. And the reason is the vertical angles theorem. From there, that they tell us that means that angle 1 equals angle 3 and angle 2 equals angle 4. And that would follow from definition of congruent angles. From there, they tell us that angle 2 and angle 3 equal 90 because of substituting into this equation here. So angle 2 plus angle 3 equals 90 degrees. And the reasoning would be substitution. And so if angle 2 and angle 3 equal 90, then angle 2 and angle 3 are complementary. And the reasoning would be definition of complementary angles. And so that would be your 2-column proof there. Okay? So we're going to look at this one. We want to prove theorem 5.4. If two lines are perpendicular, then they form congruent adjacent angles. So it tells you that lines S and T are perpendicular, and angles 1 and 2 are congruent adjacent angles. So we're going to start by doing a paragraph proof on this one. Just so that we can practice it. And I'm going to type it out here so that it'll go a little bit more quickly and it's more legible. Alright, so for our proof, I'll say we are given that lines S and T are perpendicular. So by the definition of perpendicular, that means that angles 1 and 2 are right angles. So therefore, angles 1 and 2 are congruent because all right angles are congruent. And the book says by theorem 5.3. So if you wanted to put because of theorem 5.3 instead of because all right angles are congruent, you could do that. Okay, so now angles 1 and 2 are congruent. Now we need to prove they are adjacent. So angles 1 and 2 are adjacent by the definition of adjacent angles. So therefore, angles 1 and 2 are congruent adjacent angles. So that could be your proof for that one. So again, paragraph proofs can be a little bit quicker just because of the format. It is just as you are writing it, or maybe as you're explaining it to someone, you would write what you would just speak to them. So hopefully that helps you a little bit with your paragraph proofs and your flowchart proofs. We're going to look at our challenge question today. So we want to prove this one. So it doesn't tell you whether to do a paragraph proof or a 2-column proof or a flowchart proof. So we can do whichever one you want. I'm going to not do a paragraph proof just because it's a lot of angles here. And so I'm going to do a flowchart proof just so we can practice it. So we are given angle ACB is congruent to angle DBC, and angle ABC is congruent to angle DCB. Okay, so this angle is congruent to this angle, and this little angle is congruent to this little angle. We also know that BC is congruent to BC from the reflexive property. And so all three of these together tell us that triangle ABC is congruent to triangle EDC. Not E. DCB. Okay? And then if these two triangles are congruent, that means that angle AC has to be congruent to angle BD. And the reasoning would be CPCTC. Whoops, I left off my justification here. That would be by angle side angle. So that would be your proof for that one. So hopefully y'all got most of that one right. You do have to practice your proofs over and over and over again. So your homework is 1 through 30. Make sure that y'all do those so that we can go over any questions you have tomorrow.